I can think of a few ways to solve this one. One way is just to look at it and go, p is definitely minus 2 because 2 to the minus 2 is a quarter. Another way to solve it might be to say, I'm going to try and make both sides look the same. The left-hand side is 2 to a power. Can I make the other side 2 to a power? Well, let's make that 4 to the minus 1 first, because then it gets rid of the fraction, which was a bit messy. And now, well, that would be 2 squared, because 4 is 2 squared. And then if I've got something to a power, you multiply those powers together, so that'd be 2 to the minus 2. Oh, so p is minus 2. There you go. So there's another way of doing it with a bit more algebra. And just to point out, to get from here to here, what I used was the fact that x to the a to the b is x to the ab. I'm going to spot here that I've got x to the a times x to the b, or that kind of situation, and where it is that, you just add the powers, because it's kind of like a tally chart. Okay, so I need to add a half and a third. Okay, so let's make them so that their denominators are the same, because that way I can add the fractions. So that'd be 5 over 6. That's a little bit of working there. And that means that the answer is x to the 5 over 6. If you made the mistake of saying that that was x to the, say, 1/5, so that's wrong, what I say to my students is just be really careful. You need a lot of... I've done a lot of work as a mathematician, not just teaching, and you often have scraps of paper lying around, and if you're adding powers, you'll just write down a half plus a third and just work it out. You won't do it in your head, because once you've been doing it for long enough as a job, you feel the pain of, if you just make one mistake, then that can be hours of work down the drain. So you're just extra careful. So if you do a sum, you just write down what the sum is, just to definitely get it in your head that you're doing it correctly. Because when you write it down, that will often, for a lot of people, trigger that memory because of the visual learning. Oh, I've got to make sure I add fractions correctly. Anyway, so just watch out for that one. And the answer is definitely x to the 5 over 6. So this is an in the form question, and notice it's then got kind of this indicates that there's a list following. You could also just use a colon or whatever, or maybe just not even have it. Might just have a dot 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 or something. Anyway, so 64 is 8 squared, or it's 4 cubed, or 2, 4, 8. Let me make sure I get this right. 16, 32, 64. 1, 2, 3, 4, 5, 6, or 2 to the 6. That's supposed to be a 6. If you want a bit more help with that, because I did go rather fast, how might we have done that? Well, I think I would just spot that 64 is larger than 8, and I'll just go, right, well, 8 to the 1 is 8. 8 squared is 64. Oh, look, I've got it already. And then just use the same kind of method. You notice I did use that for the 2. I like to make sure I definitely get the right number when I do a 2 to the power. This, by the way, is one of the reasons that the number 64 crops up in a lot of questions, because there's quite a lot of patterns associated with it, and it means that the person setting the question can make the answer quite a nice integer. So this is an in the form question. So we want it to mean 8, but be written differently. So, well, I'm just going to go for it straight with the answers. That's 2 cubed. This would be 4 to the 3 over 2. Talk about that in a moment. That would be 8 to the 1. That would be 64 to the half. None of these are minus. There's no minus powers or negative powers, and that's because there's no fractions involved, so we don't need to turn anything to a fraction. So it's going to be some number greater than 0. And the reason that was just a half is because we know we need to make the 64 smaller. And then I just kind of run through some numbers in my head, and I just go, oh, square root is 8, that works. So this is kind of how I'm solving it anyway. This one can actually be quite tricky to spot, but yeah, it's just 8 to the 1. And they've said write it in the form 8 to a power, so you have to put something there. So you put the 1, which is a placeholder that doesn't mean anything. Now, in my experience, this is the one that a lot of people find difficult. The way I would think about it is, what's 4 squared? Well, actually, the way I would think about it is I just remember this one. I always remember that 4 to the 3 over 2. Let me just undo that, just want to make that really clear. 4 to the 3 over 2 is 8. It's a really common one that crops up. Similarly, 9 to the 3 over 2 is 27. Same sort of pattern. This idea that if you spot they're both in a particular times table, so this is in the 2 times table. Oh right, well then let's drop it down to a 2 and then take it up to 8. Both of these are in the 3 times table, so let's drop it down to a 3 and then take it back up to 8. Hence you're square rooting and then cubing both of them. Yeah. What is the value of n? I would personally approach this like this. I would say I would just do one thing at a time. That's y cubed on the top. Now I'm going to combine these two as y to the 3 minus n. I'll talk a little bit more about how I did these in a minute. And that's y to the 3 minus n equals, well, the square root of y is y to the half. Oh, so that means 3 minus n equals a half. So add n to both sides, minus half on both sides. That means that, so add n to both sides. So 3 equals a half plus n. And then I'm going to minus a half from both sides. So 2.5 is n. Final answer. Just to emphasize, I'm using the approach of make it look the same. So I observed that there was only one thing on the right hand side, so I tried to combine all these things together. So there would just be one thing, could make the comparison easier, and then once I had got everything the same, once I had got everything combined, I realised that this needed to be a power, so I turned it into a power so that I could make the direct comparison. It's then, once it looks similar, at some point they will look so similar that you can say, oh well, obviously 3 minus n must be the same as a half. Because otherwise they won't both be equal, because if it's y to something equals y to something, the powers must be the same. There you go, so that was kind of the approach there. I think there'll be multiple ways of doing this question. I'll just do it one way. I'm immediately going to write it as a fraction because I feel more comfortable with that. I'm then going to get rid of these brackets. Now the brackets just indicate that the 6 is acting on everything inside. So that'll be 2t to the 6 u to the 6. These are all 6's. My 6's always look a bit odd. That's 2 to the 6, because I'm not going to bother working out what 2 to the 6 is. Not until I absolutely have to. T to the 6, u to the 6. Oh look, they cancel. They cancel. And I end up with 1 over 2 to the 5, because one of the 2's cancel from the top and the bottom, which is, so that'll be 2, 4, 8, 16, 32. There we go, 32. So that's 1 over 32. It's another in the form question. It wants it to be 9 to a power. Well, let's get rid of the fraction first. There'd be a few things to solve in any particular order. I'm going to get rid of the fraction first. I'm now going to make it so it's one thing. So I'm going to use the x to the a times x to the b, because these are times together, is x to the a plus b. So that'd be 2 minus 1, which is 3 to the 1, which is 3. Now, you might just spot that that is 9 to the half. Ta-da! Yeah, I guess you just need to spot that. The only other thing I can think of, if you're finding that really hard to spot, is you could just put the 3, and then you could just put the 9 to the n. or maybe just the 9 and forget about the n and just think, well, they're both in the 3 times table, so I could write that as a 3, and then that's like 3 squared. Oh, that's squared, so now I'll forget about that because I didn't want to change the 9, so to make to make the 9 the 3, I'll square root it. Honestly, I think that just made it more confusing. I think if you're at this stage in your maths, try and get comfortable with things like square roots. That would be my thought anyway. Right, oh, it's another in the form question. I think the trick here is to write this. Don't do any working out of anything, any calculations until you absolutely have to. So I've already saved a bit of time here because I can see that that 3 squared will cancel and make that 3 cubed. Oh, and we only want it as 3 to the n anyway, so that's already solved that. Now 4 squared, that's kind of like 4 times 4, so let's just rewrite this. There's a few different approaches at this point, but 4 is 2 squared, so that will cancel and make that a 3, and then that would cancel and make it a 1. So we've got 2 to the 1 times 3 cubed. And that would be it. Maybe you wrote 2 times 3 cubed because you didn't bother to write the 1 here. Hey, or you didn't think. I personally think that's fair enough, but I mean, obviously, if you were doing an exam, it might just depend on what the exam was after. You also might have finished this off and written, well, that's 2 times 27, which is 54. Because it is tempting just to calculate it as 54, but it did ask for it to be in this form, so let's leave it like this, so that it's in the form the question asked for. There's a really quick way of doing this, which a lot of people would have done, which is just to go, oh, well, 1 over 8, I can just see is 2 to the minus 3. Alternatively, maybe you started with a 2 and you thought, well, I'll start at 2 and I'll try and turn it into 1 over 8. Well, I could do it to the minus 1, so that'll make it into a half. And then I could cube it, which would turn it into 1 over 8, because a half times a half times a half is an eighth. So the total that I've done is minus 3. So it must be 2 to the minus 3. There's going to be loads of other ways of doing it as well. I think this question is easy if you just sort of do it really carefully. Let's do brackets first, but then we do the brackets inside the brackets first. There's no brackets inside the brackets, so that's okay. So the first one we're going to do, I'll just colour in pink. I'm going to do these brackets first, which means I end up with 7 to the minus 1. Because 1/7 to the minus 1, you flip it because of the minus sign. And then if I then do minus 1, losing the ability to speak, if I've got 7, I do it to the power minus 1, it turns it back into 1/7. Possibly you did what I would have been tempted to do, is just look at it and go, well, they just cancel out, so nothing happens. Another way you might have done it is you might have said, well, it's 1/7, but I don't really care, I'll just imagine it's an x. But it's an x to a power to a power. And if that happens, you can use the fact that x to the a to the b is x to the ab, so you just times them, so that'll be x to the minus 1 times minus 1, which is x to the 1, because minus 1 times minus 1 makes plus 1. So it doesn't change it, it's just x. So if it's 1/7, it just doesn't change. A few different ways to think about that one. If I've got a 10, the larger the power is, the larger the number. So let's start with the lowest power. That must be the lowest value. And then just make the powers higher and higher and higher. Yeah, because if you draw a graph, it just kind of look like that. Maybe you don't think about it in terms of graphs, in which case don't worry about it. You might have just worked them all out. If you did, that would have been 1/10, that would have been 1, that would have been square root of 10, which means that must be somewhere between 1 and 10. That would be 10, and that would be 1000. The important thing here is to realise that 1/2 cubed, so let's just take one example, that is 1/2 times 1/2 times 1/2, which is 1/8. So that's smaller. So the higher the power, the smaller it is. So we need the highest power first, because that will be the smallest number. That was supposed to be a 3. And then the next highest would be the 1, so that would be a half to a 1. Then it would be a half. Then it would be 0. Then it would be -1. So we've gone from the highest to the lowest power, because that's how you're going to go from the lowest to the highest number. If you don't believe me, that's 1/8. That's a half. Oh, which is do you want an eighth of a pizza or half a pizza? Well, if you're hungry, you want half a pizza. That'd be 1/√2, which is more awkward to think about, but it's anyway. That's a 1, and then that half to a -1. That's going to flip, and that'll become 2. We're trying to find x. So I'm thinking let's just tidy this up so we can really see what the x is. I'm tempted to rewrite the right hand side as 5 to the 6 using the fact that x to the a to the b is x to the a times b. And on this side I'm going to change it to 5 squared times 5 to the x squared. I'm going to put 5 to the -1. And I'm going to change that to 5 to the 4 times 5 to the 2x, because I'm basically squaring, because there's a times sign inside the bracket, I'm just squaring everything. Times 5 to the -1 equals 5 to the 6. Let's combine this one and this one, so that'd be 5 to the 2x, whoops, times 5 cubed equals 5 to the 6. At this point, I'm going to be a bit sneaky. You could divide both sides by 5 cubed or something like that, but I'm going to be sneaky and I'm just going to spot that that must be 3. 2x must be equal to 3. Why? Because I know that 5 to the 3 times 5 to the 3 is 5 to the 6. Hence, I've observed that there must be a 3. And then the next step is simply to solve that. Divide both sides by 2, x is 3/2. Is this true? Answer is no. One way to think about it is, if you're going to put the 5 inside, then as it goes inside, you need to square root it, because you're going to have to do the opposite to what's to the power. So that will become √5x plus √5 squared, because that way when you square it, the √5 becomes a 5. That's quite an abstract way of thinking about it. Another way to think about it, and then maybe the abstract way will make more sense, is to take this one and multiply it out. That'd be 5x squared plus x plus x plus 1, because remember that's an x plus 1 times x plus 1. And then this side is 5x plus 5 times 5x plus 5, which is 25x squared plus 25x plus 25x plus 25. Now this one we're going to then multiply out and multiply everything by 5. So that'd be 5x squared plus 5x plus 5x plus 5. I think we can clearly see they're not the same. Wherever there's a 5 on this side, there's a 25 on this side. because these were inside, so they also got squared. And this one was on the outside, so it didn't get squared. So the answer is, so just to clarify, the answer is no. Maybe you just realised, and if you're in an exam, if you're watching this, you're preparing for an exam, you might have said the 5 is on the outside of the brackets on the left-hand side, but is on the inside on the right-hand side. So on the right-hand side, it's getting squared. So that was what we said with explanation number 1. And explanation number 2, we just said, do you know what? We'll just multiply out the brackets and show that they're clearly different. And then that, well, there you go. It's obviously not true. Is this true? It is true. Yes. We might think about it as, well, this side is like k over 1 times x to the n over p, which is kx squared over p, because we've done k times x squared, that is supposed to be a k, and 1 times p on the bottom. And then the right-hand side, that's like k over p times x to the n over 1. Yeah, did anyone notice my deliberate mistake there? Obviously that's not x, that's obviously not x squared. That's x to the n. That's x to the n. And then on the right-hand side, k times x to the n is kx to the n, and p times 1 is p. Oh look, they are the same. There's going to be loads of ways of explaining this, and for a lot of people who are really used to fractions, they might just say, well, it's obviously true. And that's okay. If that's obvious to you, that's great. And that shows you're getting more comfortable with how fractions work. If you want to start feeling things being more obvious, if you've only got times signs kicking around, you obviously can't do if this is plus and minuses, but we can just kind of join these together. And I like to extend the fraction line with the green line all the way across, and just visualize everything on the top as being on the top of the fraction, everything on the bottom as being on the bottom of the fraction. There you go, a few ideas, but if you start taking shortcuts like that green line, you have to be careful that you're only applying the correct place. So feel free to just keep doing it carefully like we did here to answer questions like this, and I think that's a really great approach. I want this in the form 8 to the q, because you can use any letter to set this kind of question up. Well, I'm straight away, I'm going to spot that this is like x to the a times x to the b, which is x to the a plus b, because I don't want to start actually working these numbers out, because I want to make my life easier. So that's like 2 to the 8. Do you know what? I'm going to use a trick here, and I'm going to say that 2 is 8 to the third. So 2 to the 8 is clearly 8 to the third to the 8, which is 8 to the 8 over 3. There you go. I'm not sure I can think of another way of doing this one, to be honest. Reason being, 8 over 3 isn't that's not a neat answer. So, but you might have kind of done a similar approach where you still made that intuitive leap at some point that 2 is the same as 8 to the third. I think that's the key thing. If you can spot that, generally that makes this question accessible and possible to do. Express 8 to the 2p plus 1 in the form 2 to the q, where q is a function of p. What that is basically saying is you've got 8 to the 2p plus 1. We want that to be 2 to a power. And in there somewhere is going to be a p. It's a bit wordy. If you're still finding that awkward to understand, you could always kind of ignore that. I always say that my general rule is, if you don't understand a bit of a question, ignore it and maybe it'll still make sense. And I think in this case it does. In the form 2 to the q. Okay, and you can end up with a p in there, and that's fine. So this is the big picture here. How are we going to make the 8 and the 2 look the same? Well, 2 cubed is 8. So there we go, we've immediately made the left hand side look more like the right hand side. We can now use the relationship x to the a times x to the, no, that's not the one, x to the a to the b is x to the a times b. So it'll be 2 to the 3 times 2p plus 1. And you could leave it like that, or you might have multiplied it out as 6p plus 3. Solve. This implies find the unknown. The unknown here will be the x. There's going to be multiple ways of doing this. I'm going to times everything by 7 to the x. Do you know what? Because that just feels like an easy way of doing it. So that gives me 7 equals 7 to the 5 times 7 to the x. I'm now going to divide both sides by 7 to the 5. So that gives me 7 divided by 7 to the 5 equals 7 to the x. I'm now going to use the fact that x to the a divided by x to the b is x to the a minus b, which means that 7 to the minus 4 is 7 to the x. We can now say that by inspection, or clearly, or in order for the two sides to be the same, the powers of 7 must be the same. Multiple different ways of saying the same thing. X must be minus 4. So x is minus 4. Just in case you can't see the green there. Solve. That means find the unknown. The unknown looks like it's an n there. And there's an n there as well. Oh my goodness, we're going to have to combine those somehow. Well, let's combine them. Let's use our indices knowledge. We know that x to the a times x to the b, which is the scenario we've got here, is x to the a plus b. So let's use that skill. X to the n plus 2 to the n plus n plus 1 equals 16. I'm now going to use, well, let's just simplify that. 2n plus 1 equals 16. When we're solving like this, we're trying to make both sides kind of look similar. We've got a 2 here, but we've got a 16 here. Let's turn the 16 into a 2 by doing this. 2, 4, 8, 16. So it'll be 2 to the 4. And we can now say, well, by inspection, or clearly, or for both sides to be equal, the 2 must be to the same power. That means that 2n plus 1 equals 4. I'll carry on in blue in case you can't read the green very easily. So then we can just solve this. Minus 1 to both sides. 2n equals 3. N equals 3 over 2 because I've just divided both sides by 2. Simplify. I'll do the quick answer first, which is to spot the cube root of x to the 6 is just x squared, because x squared times x squared is that. And then the cube root of a is 2, and the cube root of y cubed is y, and I might simplify as 2x squared y. There we go. Alternatively, you might have used powers, and you might have observed that this is x to the 6. Let me just tidy that up. X to the 6 times 8y cubed to the third. And then you might have just timesed the 6 by the third, spotted that 8 to the third is 2, and times the 3 by a third to make 1, which means you've got x squared times 2y, and then again you might have tidied that up as 2x squared y.